f of x equals to 4 sine x minus 1. So this is an example of an exam question. If you have f dash dash x like this, do not get confused about what this represents. It's the same thing as writing f of x equals to. It's the same difference between doing colons. Let's just say, if you were to write down in a sentence number of people that went to school today, and you did colon, versus number of people that went to school today equals sign. You can see the application is the same, right? So make sure you understand what this represents. It's just the same thing as saying f of x equals to 4 sine x minus 1, no problem. And when we're talking about the range over here, what we're really saying is, what are all the possible answers that this can be? When we talk about all the possible answers that this can be, we're talking about all the numbers we can get. Does that make sense to you? Which is affected by the x value you substitute into here. So when they say the x value can only be between negative a half pi versus a half pi, you know this is radians, negative a half pi radians. It just means what are all the possible numbers that this can be. So when you write down f of x equals to 4 sine x minus 1, all it's really saying is, look at what the limits are when you substitute these numbers in. Take a look at when you substitute negative a half pi in, because you know it can't be any smaller than negative a half pi. If you were to substitute that in, you'd have to make sure your calculator is what? In radians mode, shift mode, radians, 4 sine, 4 multiplied by sine, because that's what 4 sine x minus 1 means, 4 times the sine of negative 0.5 pi minus 1, and that's where you get negative 5 from. As in when it's equal to negative half pi, it's negative 5. When it's equal to a half pi, 4 times sine of a half pi minus 1, and you get 3. Do you see these two limits over here? These are the boundaries of what the x values can be. As in the numbers you substitute in here has to be between negative half pi and a half pi. When it's negative a half pi, it gives you negative 5. When it's a half pi, it gives you 3. And you can see how the numbers you substitute in here varies. It sort of changes between this number and this number, between these two limits, in this sort of region, between this number and this number, which means the answer must sort of what? Hover between negative 5 and 3. Does that make sense to you? You're trying to describe over here, you realize that this possible answer, which is what the range here means, is given by all the possible numbers between negative 5 and 3. How do you describe that this can only be between negative 5 and 3? This is how you describe it, wouldn't you? Inequalities. As in we know it can equal to negative 5 over here when we substitute this into the x value. We know it can equal to 3 over here when we substitute it into the x value. And we know negative 5 and 3 would be the boundaries for which we get the answers over here from these inputs, aka the range. So that's where we get negative 5 greater than equal to f of x less than equal to 3. Does part 1 make sense here? Part 2, if you want to find the coordinates at which the curve intersects the coordinate axes. Doesn't coordinate axes just mean, this is where you realize, if you are confused, coordinate axes just means the same thing as the x-axis, the same thing as y-axis. Meaning, when we're talking about the curve y is equal to f of x, they're talking about this equation, isn't it? It's basically the same thing as saying 4 is equal to y is equal to, 4 sine x minus 1. We're saying when we plot this graph, where is it going to touch the x-axis? Where is it going to touch the y-axis? Do we know what shape this looks like? No, we do not. But even if you did not, you wouldn't be confused as to why we make x equals to 0 and we make y equals to 0. Remember the basics? Coordinate axes over here means the points of intercepts. As in, where does it touch on the x-axis? Where does it touch on the y-axis? How do you find where it touches on the y-axis? How do you find the y-intercept? You make x equals to 0. How do you find where it touches on the x-intercepts? On the x-axis, you make y is equal to 0. So that's why over here we did x equals to 0. Do you see how we did when x is equal to 0? We get 4 sine of 0 minus 1, which is equal to negative 1. So do you see when x is 0, y has to be equal to negative 1. That's where we got the coordinate 0, negative 1 for the x-axis intercept. Excuse me, not the x-axis intercept. This would be the y-intercept, wouldn't it? 0, negative 1. Where is 0, negative 1? It's like here. That's the y-intercept. How would you find the x-intercepts? You make y is equal to 0, making this thing equal to 0, which is what we did over here. And if you do the basic algebra on this, you get 0.25 when you rearrange. Make sure you're in radians mode. And that's where you get this x-intercept from. Part 3, how do you draw the graph? The graph of this is very easy to do if you realize. Do you have the best calculator money can buy? FX101ES plus. You press modes. You press 7 for table. Do this right now. Press modes, press 7, and you'll have f of x equals to this little prompt over here. Your screen should be flickering the equal symbol like this. And then you replicate this function on there. You type in 4 sine x minus 1. How do you type in 4 sine x? We just type in 4. You type in sine. You press alpha and the right-hand side bracket to get the x. Close that bracket. Minus 1. Press equals. Make sure when they say start, start just means where do you want it to begin. End just means where do you want it to end. So negative 0.5 pi starts, 0.5 pi ends. Step is just what are the gaps you want between there. Remember 0.25 pi is the nominal number to go. It works every single time. So we type that in. And you'll see this whole grid in front of you, wouldn't you? You have x over here, f of x, negative 1.57, negative 5. You'll see these numbers in your calculator. When you see these numbers on the calculator, what do you do with these? Remember, if you're trying to sketch the graph, remember in theory, this would be difficult. As in, if you found this difficult to do, why would it be difficult? It's difficult because you wouldn't know what the shape of this looks like, is it? Isn't, by definition, every single graph, if you were to sketch it, if you had the points, you could just connect the dots? See what I mean over here? Like, if you had all the points over here that connected it, just join the dots, you'd have the graph, wouldn't you? Like, sketching is very easy if you have enough points over there, you can just sort of join the dots on. So what this table method does is it gives you the points you can just read off of on the table. This table method, it just gives you the coordinates straight away. As in, when you see negative 1.57, negative 5, you realize this just means, where did the graph begin? Negative a half pi. This means negative 1.57, which is negative a half pi, gives you a y value of negative 5. Isn't that the same thing as saying a coordinate, negative 1.57, comma negative 5? Same thing as negative a half pi, comma negative 5. See how we got that first coordinate, negative a half pi, negative 5 like this? Obviously, you're not confused about how do we draw the scale. That's pretty straightforward. Just like this thing is just going to be. Step was 1 over 4 pi, wasn't it? 0.25 pi. So negative a half pi plus 0.25 pi would be what? Negative 0.25 pi, which is what we have over here. And we're saying if we read off of it is negative 3.8, which is very close between negative 3 and negative 4 over here, which is why we have this point over here. See what we did over here? You just read off the table values, right? Below that it's 0, negative 1, so you see how 0, negative 1 like this. You plot all the points that you get from the table and then just connect, sketch it, join it together, freehand it. Pretty easy to do that for 2 marks, isn't it? Table method works over here. Part 4, if you wanted to find the expression for the inverse function and domain and range of inverse of a function, are you confused about why we did this table over here? Do you remember why we do this table first? Look at the working over here. Why do we do the table first instead of just doing the question straight up? It's a rule always, isn't it? It's always more helpful if we draw the table for f of x and f of inverse x, stating the domain and range of f of x, domain and range of inverse f of x. So I'm explaining right now how we even got this table first. As in, for these types of questions, whenever you're dealing with domain and range for inverse functions, whenever you're dealing with inverse functions in general, for 4 marks especially, you always draw this table. As in, you do the f of x, start off like this, inverse f of x like that. Would you need to be told to do that, yes or no? And then without further ado, you only fill this in what? You can only fill in what they already gave to you here. That's the only information you have so far, right? There's this, negative a half pi, greater than or equal to x. As in, you take all the information that's obvious right now, that you do know about for f of x. And you also know the range of this. You're not confused about why this is the range, yes? And then, remember the rule? Domain of f of x is the range of inverse f of x. Meaning, the range of f of x, how do you describe the domain of f of x? How do you describe the range of f of x? Domain of f of x is x must be between this and this. So that just means something in general that is between negative a half pi and a half pi will become the range of this. How do you describe the range? It's this letter, isn't it? This letter is between negative a half pi. Domain of this is describing x, which is the range of f of x. Remember they're reversed? So it just means you read this as negative 5, 3. F of x is between negative 5 and 3, but it really means is just a number in general being between negative 5 and 3, which you can interpret up here for the domain, like this. Any confusions as to how we got the table over here? This table over here. Any confusions? Why do we care about this table? What do we do with this? We do the inverse function now. We go ahead and find the inverse function. We go ahead and find the inverse function over here, which you know starts off as writing y is equal to this equation involving x. Rearrange for the x, and you surely know why it's going to be the 4 sine x. You get how that works. Sine x equals to y plus 1 over 4. So x by itself is just shift sign, and that's where we got this relationship from. So we just copy that in like that. And we wrote these two in. Why do we write these two in? Because they asked us for the domain and range. Do you see when you draw the table, how easy was it? Imagine if you didn't draw the table over here, you would have found the inverse function and then be like, what the fuck? How do I find the domain and range? Like, shit, what do I do now? Whereas from the very beginning, you adopted the habit. What's habit mean over here? You do this every single time without needing to be told. If you know it's going to be an inverse question, you find the domain and range using the table method. See how easy that table method was? We just copied in what we already had for f of x and we just replaced them, reversed them, orders. See how that works? So we just copy in directly the domain over here and the range over here. For negative 5, 3, negative half pi, a half pi.